What's good, guys? Welcome to 4.2, part 1 this leg, period 7 math. Let's go. Good chow.
All right, good chow is right. We are going to start with going over some of the questions from the quiz on 4.1, the non-graded quiz on 4.1, and then we'll go into 4.2, and everybody's silent, has their notebook out and open and ready to take notes and learn. Okay, number 1 on the quiz. What is the solution of the system of the equations below? You have only learned one method of solving systems. There are 3. We'll learn the second one today. But so far you've only learned one. So the only way to find the solution is to graph. I mean, technically, if you want to use like a testing strategy and you didn't want to graph them, you could just take time plugging in each solution to both equations and see which one works for both equations, but that's not the real way to solve it. That's just more of like a test-taking strategy, which is fine. If worse comes to worse and you're taking your EOC at the end of the year and you forget how to graph, but you want to plug in those answers, go for it. We have 2 equations. I'm going to go through this quickly, so everybody make sure you're paying attention. I don't want to hear folding papers or anything like that. We have an equation here. Everything is written in slope-intercept form. It's very convenient, right? We don't have to rearrange anything, yeah? Sure. What do I look for first?
The line.
Good, which is? Yes, very good. Just wait till I get there. I just plotted my positive 3 on the y. Yeah, it doesn't matter. Just write a lesson. We didn't even start the lesson yet. Okay, so she's also pointing out that for the slope, it says the slope, this x term, it says negative x. Is x the slope?
No.
Is x part of the slope?
Yes.
No. It's just next to it. Thinks it's so cool, just wants to hang out with the slope. X is not the slope. It's not part of the slope. It's just next to the slope or being multiplied times the slope. But if we have a negative x, that means it's a negative 1x, okay? So negative 1 is our slope, but put it in rise over run, Faith. What is it? Good, negative 1 over 1. That means we go down 1 over 1 to the right to plot our next point. Down 1 over 1, we can keep going just in case we need them to be exact, to see like we can pinpoint, get it, pinpoint, we can pinpoint the actual solution. That's the first line. Here's the second line. Negative 2 is our y-intercept. Yes, I am going through this quickly. Negative 2 is our y-intercept. And then positive 4 is our slope. Just to 4, what do I do, Lily? Exactly, I noticed, okay? I notice. You guys think I don't notice. I notice when you're messing around, even if it's not like distracting others, it is distracting you, okay? The slope is 4, what do? Put it over 1. 4 over 1 means up 4 to the right 1. Watch this. 1, 2, 3, 4, over 1, bam, right away. Whoops, terrible line. Right away I get my intersection. Where is that?
1, 2.
Yep, it's positive 1, positive 2. That's the solution. Positive 1, positive 2. If you wanted to check to make sure that's correct, what would you do?
Check it.
Plug this x and y value in to this equation and also to this equation. Make sure the equation is true. And then you're done. For number 2, this one was a little tricky for a couple of reasons. I can tell yourself now, so come back to me, okay? This one was a little tricky for a couple of reasons. The graphs don't really extend as much as I would like them to, those lines, but let's just take a look. And it's tricky here because there's no y-intercept. What does that mean the y-intercept is?
0.
0. Negative 5x, well that's a negative 5x plus 0, right? Boom, a 0 appears. Poof, it's like a magic trick, like pulling a rabbit out of a hat. A 0 appears and is our y-intercept. So we need a y-intercept of 0. There's one. There's one, and there's one. Okay, so that doesn't help at all. Let's look at the slope. Negative 5 over 1. So from the y-intercept, we go down 1, 2, 3, 4, 5, and then over to the right 1. Does that work?
Yeah.
So far, so good. Let's check the other ones and see what we can eliminate, yeah?
So whenever I was trying to replace, I didn't even know what it was and what to do, so I added 1 to it and I still did it right.
That would not work.
Okay.
Because if you add 1 to this, that makes the y-intercept positive 1. So you may have misread the graph also. Or you maybe used this one to locate it and that kind of led you in the right direction. But adding 1 is not correct. Okay, it has to be a y-intercept of 0. Now let's take a look at this. Oh, let's check the other ones. At this y-intercept, down 5 and over 1. Nope, that's not where that line is going. At this y-intercept, down 5 and over 1.
Yeah.
Possibly, right? We could even go the opposite, right? We could go up 5 and to the left 1, right? We could move our negative to the denominator. We could go up 5, 1, 2, 3, 1, 2, 3, 4, 5, and to the left 1. Yeah, that works. Okay, so this one is possible. D, we have our y-intercept here. No, that's not going to work. Down 5 and to the right 1. That's not going to work at all, so this cannot be it. Let's check out our next equation. Y-intercept is negative 6, 2, 4, 6. Yep, this line is intersecting right here. And then x is a 1x, so that's positive 1 over 1. Up 1 over 1. Right there, that's the line. We found
I
it.
wonder which one of those was like, I was being sarcastic.
Okay.
I was being sarcastic.
So but we just don't need the comments because I don't have a lot of time to teach this, okay? Does everybody understand how I found that, okay?
Yes.
Now, it had a part B. Since we found the graph, I believe the next thing it asked for is what is the solution? What is it, Faith?
We're on number 2, right?
Yeah, part B.
Wasn't it?
So the solution is down here. Sorry, I thought you wanted to give it to me. The solution would be pop.
Positive.
It's positive 1 and negative 5.
Good. Positive 1, negative 5 is the solution.
I know this one.
Guys, I can answer this question with my joke.
No.
Yes.
No.
It helps you learn why are parallel lines always fighting?
But there's no solution.
Because they can never find a solution. All right, so if you see parallel lines, the answer is no solution.
I thought it was evidently because I saw lines and it had the arrow, so I thought it was just going to keep going on forever.
But now you understand why it's no solution?
Yeah.
Okay, think of the joke next time.
And there was no solution.
Okay,
I know the answer to this one.
all right, for this one, Faith, you want to explain it?
Yeah.
Okay, go ahead.
So, what I did is I started at positive 4, and I went down 0.5, so it would be like half of a block, and then I went to the right 1.
Okay,
And I
let me,
did that before.
hold on real quick. I want to show you that they actually already graphed the lines. So that's a part that we can actually skip. They did the graphing for you. We just have to look at where they intersect and decide which coordinate pair represents this location. The location is awkward. It's in, like, inside the box rather than at one of those perfect intersections. So Faith?
Did you want the answer?
Sure. Well, tell me how you found the answer.
So, whenever you see it, like a little bit past 1, so
Yep.
it's 1, so it wouldn't be 3.4, either C or D.
Yeah.
And then it also wouldn't be A because it's not
Wait, what?
into.
What?
Hold on.
No, it wouldn't be B, my bad.
Right.
Because it's not
So
into.
she's noticing that this x value, you can determine the correct answer just looking at the x value of the point. It has to be just past the 1. Not past the 2, not past the 3, and not past the 4. Boom, 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 correct. It's a little of the ways past the 2, about a quarter of the way. See, 0.2, 0.25, a quarter of the way. Yep, and then up on the y, it goes 2, 3, and I don't know, about 3.5, 3.4, about 3.5, right? So it works perfectly. All right, a lot of people got this one wrong also, so I just want to go over it really quickly. Sure, go ahead.
Okay, so how I found it was, I kind of didn't look at the question at first, so, but I kind of knew what they were asking, like, what was the similarity with the
Where's the
It's section.
solution?
So
Yep.
basically, the number of guests, I counted the number of guests on the little line.
Okay,
For the
you
X
notice
value.
that the x-axis represents the guests. So to get the guests, you're going along the x-axis and finding where the solution lines
And
up.
10 guests, so you have the number of guests already.
Yep.
For 10 guests, it costs $250 because it's at that 250 mark.
Yep, this solution goes to the 10 on the x value, which is the number of guests. And it also is halfway between 200 and 300, which would be
Makes a
250.
little rectangle.
Okay. Does that make sense to people who had a little trouble on this quizzy quiz?
Yeah.
Are you thankful that I'm not doing this for a grade?
Yes,
Yes.
please.
Good, but still, I think most of us just need this practice. It kind of gives me an idea of where you guys are. It gives you an idea of where you guys are. We're gonna start, I've got about 10 minutes to teach the first half of this lesson. So I can do it, but I can't have any comments, papers, moving around. I need every pencil in hand. I need every note being taken. You're gonna be like, I can see smoke coming from your notebook. You're taking notes so
What?
hard. Don't need the comments, don't need anything. I'm allowed to joke, you guys just be entertained without commenting, okay? That's how my class works. Oh, you good back there?
Yeah.
All right. I think we found Bo's new seat. He's so well behaved. He's like a little puppy. Okay. Here we go. Oh, you know what? I decided that I actually don't like this as the first example. It's ugly and it's got a fraction, so I don't like it. We'll go back to it at the end. I'm actually going to skip to the triad problems because they're a little bit simpler, cleaner, no fractions. Well, there's one fraction, but it's a half. No big deal. So I'm going to start with this and go backwards. Okay? So we've learned about graphing. We just did a whole lot of graphing, seeing where those intersections, seeing if they have an intersection, no, seeing if they're on top of each other, which, hey, no question on the quiz had that, right? Interesting, right? Okay, so we're doing the exact same thing. We are solving systems of equations. We're trying to find the solution to systems of equations. But this lesson involves no graphing. This lesson involves substituting. Taking a value from here and putting it over here. We know what substitution means, right? What does it mean? Yeah, replace, put something else in place that hopefully has the same value, right? I mean, if you're substituting something in real life, like if you're like, can I have a sugar substitute, please? I'm not using white sugar right now. Can I have coconut sugar? Okay, you're substituting your white sugar for coconut sugar. It might not be the exact, it might not look the same, might not taste the same, but it's essentially doing the same thing. It's sweetening your coffee or sweetening your tea. Okay, right? So we can substitute something that has the same value, even if it looks a little bit different. Or tastes a little bit different. Don't worry, we're not gonna be licking any of the numbers today.
Oh.
You can laugh, you can accept the funniness, but please don't comment. I understand if the teacher says licking numbers, it's hard not to comment, but here we go. We're going to use substitution to solve each system, okay? We're going to start with A, and they're not in slope-intercept form, but how am I going to graph it if it's not in slope-intercept form?
So you just move.
Oh. How am I going to graph it if it's not in slope-intercept form?
You put it in.
Nope. How am I going to graph it if it's not in slope-intercept form?
Substitute. Put it in.
That's what I tried to say.
No.
You finish my sentence.
She said how many?
It was a trick question, sorry. I tricked you guys. I said, how am I going to graph it if it's not in slope-intercept form? You're not graphing. Remember I just said that you got it right too, Vincent. She just knew, like, she was on my level. She was like, you're not graphing it. She's like, I know you're tricking me. Okay? We're not graphing. We are solving by substitution. No more graphs for this lesson. You can do it when you want. But for this lesson, we're going to solve by substitution. So they don't have to be in slope-intercept form. You got to pay attention. I'm entertaining. I'm making jokes. I'm talking about licking numbers. You've got to pay attention. Okay? What other math teacher said that? Come on. Okay. So we don't want them in slope-intercept form. We don't care. What I do like about this is that this expression actually gives me the exact value of x. What's my value of x in this equation? I said expression, I meant in this equation, what is the exact value of x? Nope. Nope.
1 plus
The exact value is y plus 6. But that's not exact. It sure is. It is the exact value of x. It might not be as pretty as just having a number, but we'll get there. We're going to use this exact value, saying if it says x equals this, then that means x equals it, right? That means y plus 6 equals x. So if I know that about x, can I use that information
Yes.
and maybe replace this x or substitute it with this exact value for x? Why would I want to do that? Well, let me show you. If I get rid of this x and I replace it with an expression that has the same variable as this, then I have y plus 6 instead of x plus y equals 10. Notice how we used a value for x to get rid of x and only be left with the variable y. Why would we want that? Because if we only have one variable, then we can solve for the exact number value of the variable. I don't want to know the answer, so if you're raising your hand to give me the answer, let's not be disappointed because we actually want to learn the process, not just answers, because that's not going to help us. So, why do I have a y here and a y here? How many y's is that? 2 of them. Okay, so I have 2y plus 6 equals 10. Now let's solve. Just shout it out. What do I do?
Minus 6.
Good. What do I get?
2y equals 4.
Good. Now what do I do?
Divide.
Divide by 2.
What do I get?
Y equals 2.
X equals
Y equals 2. Yay, I found the solution.
No, you didn't.
Wait a second.
What about x?
What'd you say?
What about x?
Exactly. What about x?
X doesn't matter.
Careful, don't fight into the camera area. He's right. What about x? We've found half of the solution. The solution is the intersection of these lines, which means it's a coordinate pair. So the solution has an x value and a y value. We have found the y value. Somebody tell me how in the world we're going to find x.
You're gonna plug in 2 for y.
Exactly. We're going to go back to our equations. We're going to take our y value of 2, and we're going to bring it, and we're going to put it in whichever equation I want. Which equation do you think would be best, the first one or the second one? The first one. Because if we have y, and we're trying to find x, I'm going to choose the equation that already has x by itself. So I can plug my 2, and then just solve for x. 2 plus 6 is 8. So x is 8. What's my solution?
8.
Positive 8, positive 2. And do you understand why I don't want the solution before we've gone through the whole process? Because we're learning now, okay? Does that totally make sense?
No.
Really? Well, let's do another one.
Yeah,
Do my exercise of all this erasing. Okay. We have another system of equations. Ew, they're not in slope and step one. How am I going to graph them? You don't graph them. I mean, you could if you wanted to. You could still find the solution. But for today, we're learning about substitution. But it doesn't say what the value of x is. So how do I plug something in for x? That's what I did here, right? It says y equals this.
We solve for y.
So we're going to use this value as our y value. Because it says y equals, I can tell you're zoning out, it says y equals this. So that means, now remember, these two, if it's a system, these two have to work together to find the solution. Okay, unless you're parallel lines, and then it'll never happen. But I can replace this y with this entire expression, 2x minus 1. What? It says y equals this, so I'm going to take this y and substitute it, replace it with this expression, so that I can get rid of this excess variable and just have my x variables. I'm going to rewrite the whole thing. I still have my 2x. I have plus 3. But since the 3 is being multiplied times y, I want to put everything in parentheses to show that my y value is being multiplied times 3, just like it shows right there. Is everybody good? Then continuing to write equals -7. Now, I just have to solve for
Y, X.
x. I can't combine my terms yet, right? Because I have to
You can distribute
first, right? Okay. So I'll distribute. I've got 2x and I've got plus 6x and I've got. I just want you to feel it. When I talk.
-4.
-3
Whoops.
equals -7. Now I can combine and I get 8x minus 3 equals -7 plus 3 plus 3 and I get, I'm gonna just bring it up here, 8x equals
-4.
-4, divide by 8, divide by 8, and I get x
-1/2.
equals
-1/2.
-1/2 is correct. Remember, it's 4 over 8. That equals,
We're getting rid of the.
no, you can't divide the denominator by the numerator. That's breaking all the rules. Okay. Nope. 8 over 4 would be 2. 4 over 8 is 4 divided by 8.
Grace, pick it
Okay,
up.
yes, I know, it hurts, but it's okay. So we have our solution? We have our solution?
Yes.
No, we
No.
have half of our solution, right? We have our x value. We need our y value. So I'll have my x value as -1/2, or you could write -0.5 is fine. How do I get my y value? What?
You have to take the -1/2 and put it in the
Yeah. Now I'm going to take my x value of -1/2 and I'm going to plug it back in. If I want to solve for y, which one do I want to choose? Equation 1 or 2?
1.
Yeah, because it's already solved for y. Girls, in the back? No. All right, so I'm going to replace my x here with that -1/2, and I've got y equals, back up here, y equals 2 times x, which I'm replacing with my -1/2 x. I'm putting my 2 over 1, so when you multiply, everything stays in fraction form. And then I have -1. Now I just solve. Cancel my 2's because I have 2 over 2, that's 1. 1 times -1 is? 1 minus 1. Kill the cockroach, change the sign, and I get y equals -2. My y is -2. Is that my solution?
Yes.
Yes.
You're
Now,
putting it there.
before you go, just know, did I forget to press record? Oh, that's okay. No, it's okay, it's okay. That is my solution. If you ever wanted to check to make sure you did it right, just plug it back in to your equations and make sure it works. Make sure the equal sign is true.
Like that,